In example 4, we need to graph and analyze this inequality. Y is greater than 1/2 log base 2 of x. So there's a couple different notes here before we start. Take a look at this inequality and notice that first of all it is an inequality, so we're definitely going to have to shade. And we also want to take a look at this sign. That'll tell us whether we're going to have a dashed or a solid line. There's no equal to line here, this is just a greater than sign, so we'll have to write a dashed or dotted line when we do graph this. Also, here we have a base of 2, and this 1/2 here is going to narrow or widen the graph. To graph this, we're just going to go ahead and treat this greater than sign as an equal sign, although it's not, and we will try to solve for x here. So to do that, let's multiply 2 on each side, so we're going to be left with 2y is equal to log base 2 of x. The 2's would cancel here. 2 over 2 is 1, and that's 2y. And then we can change this into exponential form, so the base is 2. We're always solving for the exponent in a logarithmic equation, and then x here would go off to the right hand side. So to make our t-chart, we've got y over here, and we can pick nice values to work with for y. How about let's go with negative 1/2. So if y is negative 1/2, 2 times negative 1/2 is negative 1, and 2 to the negative power is 1/2. We could choose another value. How about 0? So 2 times 0 is 0. 2 to the 0 power is 1. Pick another value, maybe 1/2. 2 times 1/2 is 1. 2 to the first is 2. And we could continue on with this. We could go with 1 for the next one, and that would be 2 squared. 2 times 1 is 2, so 2 squared would be 4, and we could keep going and on and on. Remember that when we graph this, it's going to be dashed. We've made a note of that up here. So we're going to plot these points. We're just going to connect them in a dashed line. Also note that there is no shift in the left or right direction. There's no number here hanging out by x. That's inside parentheses. And so our vertical asymptote will be the y-axis right here, or the line x is equal to 0, same thing. So let's plot these. We got 1/2, negative 1/2. We have 1, 0, 2, 1/2, and 4, 1. And that's kind of what we expected to happen here. Looks like this graph is narrowed with respect to the x-axis, but it looks like it would kind of widen out a little bit with respect to the y-axis. So this 1/2 here is just stretching or shrinking, I guess you would say, the graph a little bit. Remember that we're going to do this with some dashes, so we can graph this line right here. If we analyze this first, we can write down that our asymptote is x is equal to 0. Our domain will be everything that's to the right of 0, but not including 0. And our range, then, we could really have any real number, negative infinity to infinity, just the same as the other ones we've graphed before. The one thing that's different, though, is we need to shade here. So what we should do is we should pick a test point, and if we do that, we can pick any point, and usually it's 0, 0, and that would be a nice one to pick, but in this case that won't work because x here is 0, so you really, I guess you can't pick any point in this case because x has to be positive. So let's pick another value here. Let's go with 4, 0 maybe. So we're going to pick this point 4, 0, and we're just going to test that and see what happens. So we're going to test 4, 0. So y is 0. We've got 1/2 log base 2 of 4. And 4 is a nice number to pick here with this base of 2 because we can figure out what the log base 2 of 4 is. And this is asking us, this not the 1/2 here, let's just look at this log base 2 of 4. This is asking us 2 to what power is 4. And so we can see quite easily that that is 2. 2 squared is 4. 1/2 of 2 is 1. So we have this statement here, 0 is greater than 1. This is false. So don't shade over 4, 0. We need to shade over everything else. So we're going to be shading over here on this side. We don't want to shade anywhere to the left, though, because our domain states that x has to be greater than 0, or from 0 to infinity. So if you're going to shade this in, we want to just shade in right over the top of the graph here. And then if you can, you can shade in this area down here as well. So all those values would work as well.